Now the next we have anodizing. That what do you mean by anodizing? So simply it is a process of that converts metal into a decorative, durable, corrosion resistant anodic oxide. That means we are covering the metal with the oxide layer of aluminium, that keeps them durable, long life, decorated, and then corrosion resistant. No corrosion takes place further. So this is a protection. This is the layer formed to protect the metal simply. So anodizing is given here. It is an electrochemical process. It is done through electrolysis, so that's why it is called electrochemical process, that converts metal surface into a decorative, durable, corrosion resistant anodic oxide. Clear to you? It is a process of electrolysis in which we take two electrodes that is made up of graphite. One is anode and the second one is cathode, and we will take the solution of electrolyte in which we are adding concentrated H2SO4 or concentrated HCl. It is explained to you earlier in our previous chapters. So aluminium is ideal to anodizing. Aluminium is ideal to anodizing, although another metals we can use here, titanium and magnesium we can also use, but aluminium is ideal for this process. It's a process of forming a thick oxide layer of aluminium. In this process, a thick layer of aluminium oxide is formed on the metal. This aluminium oxide makes it resistant to further corrosion. So it makes the metal to resist for the further corrosion. So the further corrosion do not take place on that. Similarly, during anodizing, a clean aluminium article is made the anode. Clean aluminium article is made the anode and is electrolyzed with dilute H2SO4 acid. And which acid we use to electrolyze? Dilute H2SO4 acid we are using here. Oxygen gas evolved at anode reacts with aluminium to make a thicker layer or protective thick layer of oxide. It can be dyed easily to give an article an attractive finish. So this is the process of anodizing, in which we are covering a layer of aluminium oxide over the another metal to protect it, to durable it, to decorate it. So this is the process. Just now, after summarizing our all above discussions, we concluded that after summarizing the above discussion, it is obvious that there are some exceptions. So sodium is the most reactive. We have seen sodium catches fire even if we are keeping it on our palm. So it is most reactive. In the reactivity series, sodium is the most reactive. Magnesium reacts less vigorously. Magnesium burns with a dazzling white flame, but it is less vigorous as compared to the sodium, implies that it is less reactive than sodium. But depending on reaction with oxygen only does not decide. This is not only the reason just we can decide that which metal is reactive or which is not reactive. So on the discussion of reaction with air, we cannot decide that this is the most reactive metal or this is the less reactive metal and we can make a reactivity series. No. So we have to choose another option also. We have to discuss the reaction of metals with water also. We have to discuss the reaction of metals with steam also. And after summarizing the all discussions, we will classify the metals in the reactivity series, that which is the most reactive and which is the least reactive. Clear to all? Clear, students? So we are classifying the metals in the reactivity series, that which is the most reactive and which is the least reactive. Here we done the reactions only with the oxygen. So depending on the oxygen only we cannot decide that which is the most reactive and which is the least reactive metal. So we will discuss the reaction of metals with water also. Okay.